This video is going to look at the second step of our mole calculations. And that second step is to use the ratio to work out the moles of the other chemical. So in this question, we are asked to look at the mass of oxygen required to produce 11 grams of propane. And in our first step, we converted this 11 grams of propane into the number of moles. Now, if we look at our balanced symbol equation, we only then need to focus on those two chemicals. Everything else can be ignored. Sometimes these chemicals will be on the same side of the arrow, sometimes they'll be on different sides of the arrow. It doesn't matter. We just have to identify the two chemicals that we're looking at. And in this equation, it's the mass of oxygen. So that's why we're zooming in on our oxygen, and our propane, which is why we're zooming in on our propane. So essentially then, what we have in this equation is we can see we have 1 mole of propane and 5 moles of oxygen. So that's the big numbers that are in front, remembering, of course, if there's a 1, we don't write it. So 1 mole of propane then will require 5 moles of oxygen to react. But as we've already worked out in the first step, when we have 11 grams of propane, 11 grams is actually 0.25 moles. So in terms of a ratio, what we want to say, right, if we had 1 mole of propane, that would give me, or that would require, 5 moles of oxygen. 0.25 would then require 5 times that. So we can say, quite simply, the moles of oxygen required is 0.25 times 5, which is 1.25 moles. Or if we want to set it out slightly differently, we can say that my propane to my oxygen is a 1:5 ratio. So if I have 0.25, I times that by 5 to get that up to my 1.25.